Okay, so we are sometimes faced with the problem of determining what sort of elasticity the goods that we buy in the market or supermarkets face. So I have here Colgate and Close-Up. You probably know that these two products, they're toothpaste, by the way, they are normally used for brushing our teeth. So if you don't find Close-Up in the market, you will buy Colgate. Or if the price of Close-Up is too high, you will switch and buy Colgate. Yeah? So whatever happens to the price of Colgate would affect the quantity demanded of Colgate. Now, because they are substitutes, when you do the calculation, it's unlikely to find the answer less than 1. The answer that you're going to find for this is likely to be greater than 1. What that means is that when goods have substitutes, the outcome of our calculation is always greater than 1, most of the time. Okay? All other things being equal. But let's look at another example. Let's look at face mask. Now we have coronavirus. So I have here disposable face mask. Yeah? We need it now. You can't say the price is gone up, therefore you're not going to buy it. You have to buy it regardless. Yeah? So even if the price, like in my case, I went to the supermarket and the price was much higher, more than 25% higher than I normally would buy from the pharmacy. I still had to buy it because it's needed and it's a government requirement. It protects my health. So you can see that the elasticity of this product is likely to be inelastic. In other words, even if the price goes up, you still have to buy it. All you can do is to reduce the quantity you buy by a little margin because you still need it anyway. The same applies to salt. I have here salt. Yeah, let's tell you. The salt, there is not really any substitute for salt. You know, some students tell me in my classes that, you know, lemon can be used as a substitute, but really, do you really want to cook food with salt, or do you want to cook food with lemon? So there's a bit of problem here. In my view, I think salt has no substitute. Therefore, when you do the calculation, the elasticity for salt is likely to be inelastic. So for mask and salt, inelastic. For these two products, Colgate and Close-Up, elastic. So let's look at some of the rules. Okay? So I've put here, elastic means the calculation. This PED here is the outcome of your calculation. If it's greater than 1, we call that elastic. That's the rule. Just take it like that. Second, inelastic. Okay? As in the example I've explained, salt and the face mask during COVID-19, the PED, the price elasticity of demand, is likely to be less than 1. Whatever answer you calculate is going to be less than 1. Okay? These are the two ones that the two rules that we normally get concerned about, but there are other rules as well. There is unitary, so I'm going to write that down. 3. Unit, elastic, demand. Here, your PED is going to be 1, exactly 1, equals to 1. Okay? So it's unusual to find a good that follows this sort of thing, that exactly a 100% change in price is going to lead to exactly 100% change in quantity. It's unlikely to find this in the market, but it's one of the rules. The fourth one is perfectly elastic. And I'm going to leave perfectly elastic. Here, your PED is likely to be something we call infinity. Okay, what does that mean? Well, it means that price remains at one value. Price doesn't change. What is actually changing is the quantity. So when you do your calculation, you're going to come out with a very large number. Actually, in mathematics, there's no such thing as infinity. If I ask you, show me an infinite number or an infinity, you're not likely to write any number for me. Infinity just means you have a very large number which doesn't end. The very last one 5 is perfectly inelastic. Okay, and for this one, PED is gonna be 0. Wow. I'll explain the last one a little bit, okay, because it's very, very interesting. Number 5, point number 5 here, what is happening is your demand curve is perpendicular to the horizontal line. In other words, you can see that this line is a very straight line, and although price is changing all the time, quantity remains the same. Quantity doesn't change. So the Q has a heart. Quantity doesn't change. And what type of goods do we put under this? Well, it's hard also to find examples. But you can think about very close examples. Something like a life-saving medicine. A life-saving medicine like insulin for diabetic patients fall under this category. Why? Well, imagine that you go to the pharmacy. If you're diabetic, you go to the pharmacy 2 weeks ago, and the price per insulin is $50, for example. Yeah? You're gonna buy the same exact quantity because that's what the doctors have prescribed for you. You're gonna buy the same exact quantity, but let's say you go to the pharmacy the next week and the doctor says to you, the price has gone up. Price has gone up to $100. Again, you're gonna buy exact same quantity. Okay, the quantity doesn't change for perfectly inelastic goods. So those are some examples that I can think about. So these are the rules. There are 5 of them: elastic, inelastic, unit elastic, perfectly elastic, and perfectly inelastic. These are the rules of price elasticity of demand. Thank you.